So this lesson is on checking derivatives with the graphing calculator. So let's do one. I will say f of x is 3x squared minus 4x plus 2, and I want to find f prime of x. So f prime of x is the derivative with respect to x of 3x squared minus 4x plus 2. So f prime of x is the derivative with respect to x of 3x squared minus the derivative with respect to x of 4x plus the derivative with respect to x of 2. 3 times derivative of x squared with respect to x of x squared minus 4 times the derivative with respect to x of x plus the derivative of a constant. Remember, a constant function is horizontal. Slope is 0. Derivative of any constant is 0. The derivative of x squared, remember the derivative of x to the n is n x to the n minus 1. So the derivative of x squared is 2x to the 2 minus 1, or 2x to the first. The derivative of x to the first is 1x to the 0, or the slope of x is just 1. So we get f prime of x, we believe, is 6x minus 4. Now, how do we check that on the graphing calculator? What I'm going to do is I'm going to plug this function into the graphing calculator and let the calculator determine its derivative and see if that derivative matches this graph. So I will pull up the graphing calculator and I will put in what I believe, put in my question first. So y is 3x squared minus 4x plus 2. And I want to graph his derivative. So I'm going to turn this function off. I just want to graph the derivative of that function. Now, how do I find that? Math, numerical derivative, which is number 8. Take the derivative with respect to x of the function y1. So vars, y vars, function y1 at every point x. This should graph that. This should graph that. So if I go ahead and graph that version, which will be in red, that's the derivative of my original question. This is what I get. Let's go with a better zoom. Let's go with zoom standard maybe. And I see that graph. And what do I think the answer is? I think it's supposed to be 6x minus 4. So if I look at the graph, so we have the derivative in red. Now in black, I will graph 6x minus 4. Is it the same? And notice it graphed it right on top of it. So that makes me feel pretty good. So that's our basic strategy. Now let's do some more challenging kinds of derivatives. So let's go with a quotient rule problem next. How about g of x? Equals 2x minus 3 over x plus 4. We want to take the derivative. We're going to use the quotient rule. U is 2x minus 3. V is x plus 4. U prime is 2. V prime is 1. What's our rule? Remember, U over V prime is U prime V minus UV prime over V squared. What do I get? G prime of x. U prime V, 2 times x plus 4, minus U V prime, minus 2x minus 3 times 1, all over V squared, all over x plus 4 squared, which is 2x plus 8 minus 2x minus 3 over x plus 4 squared. Next up, what do I get? G prime of x equals 2x plus 8 minus 2x minus 3 become plus 3 over x plus 4 squared. 2x minus 2x, that goes away. 8 plus 3 is 11 over x plus 4 squared. So that's what I believe the derivative of that original function is. Let's take a look. Let's go back to the calculator. We are going to put our original function in y1, put our derivative in y2, and put what we think our answer is in y3, and see if y2 and y3 match up. Our original function is 2x minus 3, 2x minus 3 over x plus 4. I don't care to graph that, so I'll turn that off. But I want to look at its derivative. So the calculator determines the slope of the tangent at every point. Math, numerical derivative number 8. Derivative with respect to x of that function y1, vars, y vars, function y1 at every point x. And this will graph the derivative, and zoom standard is probably good. There is the graph of the derivative. Could that be the graph of 11 over x plus 4 squared? 1, 2, 3, 4. Might you believe there's an asymptote here? Maybe so. But is it 11 over x plus 4 squared? That's what we want to find out. What do we believe our answer is? We'll turn the derivative function off for a short while. We believe the answer is 11 over x plus 4 squared. And what does that graph look like in black now? It's an error, of course. 11 over x plus 4 squared, not times. Try that again. Is that the same that we had before? So that was the red function. The red function was the derivative. Do the red and the black functions match up? And I think it's probably fair to say they do. Notice how the one was constructed on top of the other. All right, let's do one more, this time using a chain rule kind of thing. So this time, we will let k of x equal the square root of cosine 5x. So we have a multiple layer problem here to work with the chain rule. So k of x is cosine of 5x to the 1/2 power. So k prime of x is the derivative of something to the 1/2 power, which is 1/2 something to the negative 1/2 times the derivative of the something. The something, of course, being cos 5x. So it's the derivative of cos 5x to the 1/2. So then you pull the 1/2 down, decrease it by 1, 1/2 minus 1, negative 1/2. So it's 1/2 cos 5x to the negative 1/2 times the derivative of cos 5x, which is going to be another chain rule for us to work with. So this is 1/2 times 1 over cos 5x to the 1/2 times the derivative of the cos of something. Derivative of the cos of something would be minus the sine of something times the derivative of the something. Minus the sine of something times the derivative of the something, but the something this time is 5x. So minus the sine of 5x times the derivative of 5x. So where does that put us? We are now at 1/2. 1 over, I'll change that to square root of cos 5x. Times upstairs, we have negative sine 5x. Times derivative of 5x would be 5. So let's try to write this as a single fraction. 1, 1, negative 5. So negative 5 sine 5x. Upstairs. Downstairs, 2 root cos 5x. negative 5 sine 5x over 2 root cos 5x. We want to check that to see if that's right. So that's our guess for the derivative. We're going to graph that function, excuse me, we're going to graph the derivative of that function, see if it matches this function. So let's pull up the calculator again. So the original function is square root of the cosine of 5x. Make sure you are in radian mode. Quickly make sure of that. It's indeed it is. So I have y as a square root of the cosine of 5x. What I believe its derivative is upstairs, negative 5 sine 5x. Divided by downstairs, 2 times the square root of cos 5x. And just pay a little bit of attention to the order of operations. I do not want to have the first function drawn. I just want to graph its derivative. I want to see what it looks like. Since this is a trig function, I'm going to do a zoom trig, although I expect it to behave rather strangely. That's pretty strange. So when is cosine positive? Maybe I'll just adjust my window from negative pi over 2 to pi over 2. Again, just to get some idea of how this is behaving. Okay. Is that the same thing I get for my k prime? So we see that's in red. What did I think the answer was? I thought it was negative 5 sine 5x over 2 times the square root of cos 5x. We're going to see if that matches up. So upstairs, well, that was upstairs. I haven't done the derivative. Now I'm going to take the derivative of y1 and see if it matches. So let's do it that way. Math, derivative is number 8. Derivative with respect to x of that function y1. So this time I wrote in what I thought the answer was first. Now I'm going to check to see if it agrees with the derivative. So we'll turn off the red function. And the black function is the derivative of the square root of cos 5x. Let's see what that looks like. Was that the same as the red function? Notice how the red function graphs right on top of it. And if interested, you could always take a look at a table to look at them instead. Maybe start at 0, go up by 0.1. Just check a few points and see if they match up. You'll notice y2 and y3 agree at least at those 3 points. You can back it up a little bit. And we can see it essentially agrees. Remember, by the 3rd decimal place, depending on our h, we may have some disagreement. But our graphs look pretty good, so I'm confident I have done that correctly.